Hi guys, sorry I am not in class today. I am at a meeting with a couple other teachers and Mr. Roeder, but this will be your first flipped video for 6th grade. And just to remind you, when we do a flipped video, it's very similar to how Mrs. Menning did them last year, in that I will go through the lesson packet for you so you'll follow along through the video. And remember, whatever I write down on my paper, you need to write down on your paper. Make sure that you pause the video if needed. You can rewind it to listen to a part if you didn't quite catch what I said or if I went too fast. Pause it, rewind it. You can go at your own speed here. So don't feel like you have to just watch it through and can't go back and rewatch a part if you need to. So Polyhedra is lesson 13. And we're just going to learn a little bit about them and what they are. Okay. So here are some pictures of polyhedra here. So I'm going to draw a line. Okay, these are examples, and then down here these do not represent, so not examples. So we're going to look and decide what are the features that polyhedra have compared to ones that do not have. So if you want to pause the video and try and think of a few on your own, you can. And then I'm just going to list a couple here that are important. So they are made up of polygons. See the poly and the poly. They are 3D, so three-dimensional. We notice up here in our examples, we don't have round or curved edges. Where down here they do, so it's important that we do not have no round or curved edges. If we do, that would not be an example. And notice up here we don't have any empty spaces or gaps. Where down there in the bad examples, they have a gap, so no gaps or empty spaces, however you want to think about it. Hopefully you thought of a few more, but I'm just going to list those for now, and if you thought of something that you want to share with me tomorrow, that would be awesome. And then we're going to move on to page 2. Let's see if I can flip mine. So what we have here are, these polyhedra are a special kind called prisms. Okay. We know they are prisms because they're not pointy at the top. And they have 2 bases. Okay. The bases would be 2 sides that are opposite from each other, that are the exact same. So I'll write opposite there. So for example, this triangle on C would be opposite the other triangle. Those would be the bases. Right here, the square and the square would be the bases. And then down here are examples of pyramids. And we notice that it's a pyramid because it has triangles on all sides except for the base. And they have a pointed top. Pointed top, they only have 1 base. Okay. And triangles all around except for possibly the base. Okay, so prisms, we kind of already listed a couple up here, but we're going to list a couple more. Notice that they have like rectangular or square faces. A face is like a side of a shape. In this lesson, they call them faces. So they have rectangular or square sides. Okay. We remember that they have 2 bases that are opposite each other. As a reminder, rewind the video, pause it if you need to. Make sure that you're following along, writing down everything in your notes. So looking at the pyramids, what are some characteristics of those? Okay, we already talked about how they come to a point at the top. and they have triangles on all sides except one. They might have triangles on all sides like P, but for the majority of them, they'll have one side that's not a triangle. Okay. So prisms and pyramids, those are going to be really important as we go forward, as far as you guys should be able to distinguish between the two and how they are different. If I give you one, hopefully you can tell me if it's a pyramid or it's a prism. Okay. If it comes to a point at the top, it's a pyramid. If it doesn't, then it's a prism. If it's a 3D shape. Alrighty. For question number 2, okay, you're going to need a piece of tracing paper, and what you're going to do is you're going to trace these 3 nets and then cut them out and try and fold them on all of the black lines so that to see if they fold into a pyramid or not. So at this point in time, everybody's going to have to pause the video, including me, grab tracing paper, and you're going to trace all 3 nets and then cut them out. And then after you're done doing that, come back to the video and I will let you know where we're at. So if you want to watch me, I'm going to trace the nets onto my graph paper. My pen is not working very good. Make sure you're using a pencil. Mine's kind of coming off a little bit. Trace all of the lines, don't leave any out. So it should look something kind of like this. Then you're going to cut out all 3. Okay, use your scissors to cut them out. And I know they're kind of small, so do your best to cut them perfectly. It's okay if we're a little bit off. Trace them the best you can. Cut them out to the best you can. Only cut around the outside. You don't have to cut the lines on the inside. So you see I have 2 so far cut out. Third one. Okay. So once all 3 are cut out, you're going to fold them on all of the lines and see if they can be folded into a pyramid that looks like letter P from the following page. So if you fold on all of the lines, and these are really small, so do your best. And if we fold them all, it's kind of hard to see, but this first one, pyramid 1 or net 1, should fold into a pyramid that looks like P. And if you can't get it to fold perfectly, it's not the end of the world. We're going to practice these more tomorrow. So that net 1 looks like pyramid P, and as you keep going, you should find that net 2 also does, but net 3 does not, because there's no bottom to it. Okay, and it has too many sides. Okay, a net is a new vocabulary word for today. It is a one-dimensional copy of the polyhedra. So it's kind of like if you take a box or a polyhedra, a 3D shape, and you flatten it, what is it going to look like when it's flattened? So think of a pizza box. When the pizza box is all flat before they fold it into the box to put the pizza in, it's a flattened version, and we're going to practice this more tomorrow. So remember, if you had a hard time getting these to fold perfectly, don't panic. It's not a big deal at all. It was just practice for you to get a little bit used to what nuts are and how we fold them. We're going to be doing it a lot tomorrow, so don't panic if you couldn't get them perfectly. For question 3, if I were here, I would have given you a set of polygons, but I'm not, so we're going to look back at the previous page, and we're going to do, we'll just do A, and then we'll do Q for fun. So for A, It says decide what we would need to compose it. So for A, what would we need if we were going to draw this in a flattened version? Looks like we would need 2 triangles, one on the top, one on the bottom. And then we would also need 3 rectangles. On each side there was a rectangle. So now we're going to go ahead and draw it. So if we need triangle, and then you see if we have this triangle, our rectangles are connected to each side of the triangle. So I'm going to draw the best I can. Remember, it's not art class. We don't have to be perfect. So far I have 1 triangle and 3 rectangles, but it says that I need 2 triangles. Well, my other triangle, there are some different spots that we could put it. It's connected to the rectangles on the other end. Since this is a flattened version, it's only going to be able to connect to 1. So I'm going to put it right here. Okay? You could put it connected to this rectangle or that rectangle if you wanted to. And then if you were to trace this on tracing paper and cut it out, it should fold up and look exactly like letter A. Now let's do Q as well, just for fun, since we have time. All right, so for Q we have a pyramid here. Looks like we need a square for the bottom, so we need 1 square. I'm going to draw my square right now. And then we have 1, 2, 3, 4 sides on our pyramid. So we're going to need 4 triangles. Okay. Notice our triangles were connected to the square. So in our net, they also need to be connected. So I'm going to draw a triangle on each side of my square. And if we trace that, cut it out, and folded it up, it would look exactly like pyramid Q. Now remember, this is our first lesson with this, so there's a lot of new vocabulary going on. You might be a tad confused, especially because I'm not here. Don't panic. We will practice this more tomorrow and in the next couple days. So come see me if you would need to or would like to, but don't panic. I promise we will practice this more tomorrow. Let's review the vocabulary. Okay, so polyhedron was our first one, and it's a 3D figure composed of faces. Okay, remember, a face is a fancy word for a side of the shape. Okay. And our faces, so this right here is the face. Our faces meet at edges, so the edges would be where we would fold our net if we were going to cut it up. And then we also have vertices. Okay, remember, vertices are really fancy words for corners. So all of these corners would be vertices, and we'd have tons of edges. Okay, if we look at a pyramid, a vertex where they all meet, the face would be the shaded in area, as long as the other ones, the edge, where the faces all meet and kind of make a crease. Okay, they're all around. I didn't highlight them all, but they are all around. Okay, a polyhedron encloses a 3D area. So remember, if it's not 3D, if it's missing at the top or the bottom, then it's not what we are talking about. Okay. Here are just some examples. So if you want to show your parents what you learned about today, there are some examples for you. Okay. Then we talked about 2 specific kinds today. Okay, a prism has 2 identical faces that are parallel to each other, and those are called the bases. And when we decide exactly what kind of prism it is, we always look at the base. So this is a triangular prism because the base is a triangle and the other base is also a triangle. The one in the middle is a pentagonal prism because the 2 bases, if I try and shade them in here in red, are pentagon shapes. And over here we have a rectangular prism because the 2 bases that are opposite are rectangles. So you can always name it based on the shape of the base. The same thing is true with pyramids. Okay? We know it's a pyramid because it meets at one vertex on top. Okay? They all have that nice pointy top. And it's also named by the shape of its base. So this is a rectangular pyramid because the base is a rectangle. Here it's a hexagonal pyramid because the bottom is a hexagon. Here's a heptagonal pyramid because the base is a heptagon. And a decagonal pyramid because the base is a decagon. Okay, so by looking at the base, you can tell exactly what kind of pyramid it is. And our last vocabulary word, sorry, my paper's getting a little crooked, is a net, and it is a two-dimensional representation of the polyhedron. So if we were going to flatten it out, what would it look like? Okay, this is an example of a cube. Okay, see there are 1, 2, 3, 4, 5, 6 square faces. So if we were to trace it and fold it up, it would look like a cube or like a dice. They would all be the same. Okay, remember a net can always be cut out and folded to make a model of whatever the polyhedron is. So if you can't trace it and make that, then it's not the correct net. Remember, we're going to practice this a lot tomorrow. Our last page is just your 4 vocabulary words. What you need to do now is take your notes to the substitute and show them that you took great notes, that everything I wrote in the video is on your paper, and then they will give you the practice problems. You can go ahead and give those a try. Do your best. I know that they might not be perfect, but all you have to do is try, think about it, and use your notes as a reference. I will be here this afternoon, so if you have questions, stop by during BARC or after school, and I'll be happy to help you.